Good afternoon, everybody. Thank you all for joining this webinar, Streaming Analytics Made Easy. My name is Deepthi Mohan, and I'm a product manager on the Kinesis Data Analytics team. Co-presenting this session today with me is Jeremy Burr, a streaming specialist solutions architect. In today's session, we will cover what streaming data processing is and dive into Kinesis Data Analytics Studio, a new feature that lets you simplify creating and running stream processing applications using an interactive development environment. Let's take a look at the agenda for today's session. We will start with understanding what data streaming is and what real-time data analytics is, followed by a quick overview of the streaming services at AWS. We will then learn about how you can process data streams and why you would use Apache Flink for it, and what are the advantages of using Apache Flink and the common use cases. We'll then dive into Kinesis Data Analytics, which is AWS's managed Apache Flink service, and it's foundational for the new Studio feature. Jeremy will follow that up with a demo of the Studio feature, reading from a streaming data source using SQL and Python, and then we'll wrap up the session with some live Q&A. To get started, we'll cover the basics of streaming data at a 10,000-foot level to set the stage for the rest of this webinar. So first, what is streaming data? Streaming data is any data that's continuously generated, ingested, analyzed, and acted upon in near real time or in real time. So we are talking in the order of milliseconds or seconds. Sometimes that can go up to even minutes. Streaming data flows continuously from sources to destination, as shown on this slide, and usually hits a common set of steps that you see here from left through right. Now, this is a very simplistic view of an architecture. As customers' architectures evolve, they may look more and more sophisticated as they build out multiple use cases, and this flow can become significantly more complex, such as there could be many more stream processing applications, or the data could be sent to multiple destinations. However, if you look at the core of it, the basic steps will remain the same for most use cases. Now, the first thing on the leftmost corner of the slide is a data source. They're also called data producers. These could be a variety of things. These could be IoT devices, mobile phones, EC2 instances, other AWS services that are continuously generating data. At AWS specifically, the SDKs are the most popular data source. That's because customers can write directly from their client. It could be from any kind of device or instance directly into a storage mechanism such as Amazon MSK or Kinesis data streams. Now, SDKs are popular due to their simplicity. However, producers can be as varied as Kafka producers, Kinesis producer libraries, or even the AWS mobile SDKs. The second is the ingestion piece of this architecture, which is essentially the abstraction between the source and the streaming storage layer. It usually is just an abstraction that provides some additional value between these two, and customers intentionally may choose to pre-process their data or add encryption, authentication, or throttle some of the basic processing. This layer is mainly for ingesting into the streaming storage layer. You should note that this is an optional abstraction layer, and sometimes these may not be part of the streaming architecture at all. A common AWS solution that customers use is the API gateway. It provides additional value such as authentication and throttling. It's also very useful when there are multiple data producers. So if one of the producers is a bad actor, the ingestion layer acts as a mechanism to help ignore that particular producer and control the input into a streaming storage solution. Now, streaming storage, which is right in the middle of the slide and also at the heart of a lot of streaming architectures, is core to any streaming data use case. It provides very high volume to write very efficiently and reliably, and data is stored securely and cost efficiently. And why we call it the heart of the streaming architecture is because it lets this data that is stored be consumed by multiple consumers, and multiple data processing applications can read from it all in real time. At AWS, Amazon MSK, that's managed streaming for Kafka, and Kinesis Data Streams are the most popular stream storage solutions along with DynamoDB streams. A key advantage of streaming storage is the ability to decouple the sources and consumers. So it allows the producers to send in data at very high throughput and store it very efficiently. And customers can get data and insights very quickly, efficiently, and cost effectively. Usually the streaming storage layer can store data for a specific amount of time. It's usually retained for weeks or days or weeks, not forever like S3. Although we do hear a lot of customer requests that ask for longer term storage. Now, stream processing. This is where all the action happens. This is the most exciting phase due to all the different types of processing that can be done on the streaming data. It also has the most variety of stream processing solutions, both on AWS as well as third-party solutions. Now, stream processing can really be anything from very simple filtering to aggregating multiple different data streams, all the way to sophisticated machine learning that involves acting upon data stored on the streaming data layer. In AWS, this stream processing layer has the widest variety of services, includes things like Lambda, Kinesis Data Analytics, AWS Glue, and several open source solutions. One key takeaway for stream processing is that records are read in the same order in which they are produced. And that enables a number of use cases. That's processing order maintenance is what makes this stream processing different from other messaging systems. Finally, once processing occurs, it's sent somewhere, and that is a destination. And these are also varied in the sense that they can be dashboards or they can be alarms that are triggered in a different system, or data could simply be stored in another system like S3 or SQL and NoSQL databases, logged for later processing. Now, the most popular destination that we see is by far S3. And in some common architecture patterns, customers send their data to S3 along with some other destinations as well. Now that we have the basics down, let's look at the core AWS Streaming Services. At either end of the slide, we have the streaming storage solutions, Kinesis Data Streams and Amazon Managed Streaming for Apache Kafka or Amazon MSK are the streaming ingest and storage layers. Kinesis Data Firehose is a streaming delivery solution. So it helps in delivering your streaming data to destinations such as S3, Redshift, Splunk, or HTTPS endpoints. And the third item that we have there is the Kinesis Data Analytics, which is a stream processing solution. It's a managed service for Apache Flink. Please note that Kinesis Data Analytics works with both Kinesis Data Streams and Amazon MSK. Now, what is stream processing? Stream processing is essentially the processing of data in motion, where you are computing on the data as you go. Now, the application logic, the analytics, and all the queries that you have on the data, they exist continuously, and data flows through them continuously. And Apache Flink is one of the most comprehensive solutions for stream processing. We'll take a closer look at Apache Flink. It's the open source engine that powers Kinesis Data Analytics, and it's an open source framework and distributed processing engine for stateful computations over both bounded and unbounded data streams. So that's essentially saying that it can process both batch and streaming data. Apache Flink enables a wide variety of use cases, so you can read from a variety of sources, write to a variety of destinations, and can perform many stream processing operations, including batch processing as well. Now, the stateful stream processing is a key part of Flink because it allows something called localized and backed up application state. So what this essentially means is even if your application goes down, your application can recover from these backed up application states while still maintaining exactly one's processing. This is a key benefit to Flink, which means that you have seamless recovery of your applications without data loss. Another advantage, apart from consistent state, is that because of it, you have exactly once processing guarantees. And Flink also offers scale out processing, which means that as you add more compute, you can have very high throughput and very low latency for your Flink applications. Now, data processing in many times is also called event processing, especially in terms of Kafka and when it comes up in context of Apache Kafka or MSK. And essentially, I just want to reiterate the one thing that makes the streaming data processing or event processing unique is the events are processed in the order in which that they are received. So when you read from a source, it is in the same order as what it was received to the application. Why Apache Flink? What makes Flink very powerful are its expressive APIs. You have very simple to use and flexible APIs that make building applications very fast. It follows a layered API approach by which developers get the choice to use a very specific, very expressive API, or they can go up the stack to a very descriptive and less verbose API, such as the SQL or table API. We talked a bit about exactly once processing. And the most exciting feature about Flink, in my opinion, is that you get exactly once state consistency out of the box, which is very difficult to achieve by yourself. Exactly once processing and consistent state enables strong data integrity, and Flink achieves this through two mechanisms. It's asynchronous and incremental checkpointing, as well as a mechanism called snapshots or save points, which enable you to create and restore your application to a previous point in time. We also covered a bit of the scale-out architecture of Flink. Flink has been designed to run at scale, which means it can adapt to very large data sources and can support very high throughput. Apache Flink is also a very active community. It's one of the top 5 most active Apache projects. So there's a lot of work ongoing. It's also a very collaborative culture, and it's the top Apache project in terms of mailing list activity. So there's a lot of new features that are always coming out of the community. Now, streaming data has a wide variety of use cases, as we discussed. And the top three categories of use cases are streaming ETL, real-time analytics, and stateful event processing. Now, streaming ETL is what most customers start off with. Essentially, it's capturing the data, doing some kind of aggregations on it, and loading it to data warehouses or data lakes. About 30 to 40% of existing KDA for Flink customers use some kind of streaming ETL use case. Stateful event processing is another commonly found type of use case. About another 30 to 40% of our customers have applications that fall under this. A typical example of this includes things like fraud detection or anomaly detection, where certain rules trigger alarms or other external actions based on what they see that within the streaming data. And the third set of use cases is responsive real-time analytics, where 10 to 20% of customers have this kind of a use case. These are workloads that extract information and insight from raw data in real time. And these examples include things like quality monitoring or ad hoc analysis of streaming data. An example of this would be analysis of product updates and experiment evaluation. So we covered Flink in detail and what its advantages and use cases are. But one thing that customers struggle with running Apache Flink by themselves is that it's not very easy to do it because there are a lot of moving parts. There are enterprise stability requirements. There's layered APIs, there's consistent state, and there are a lot of tools required and a number of moving pieces to make all this work together. And also to configure them correctly so that you get the guarantees that Flink offers. Now, some of these components include things like job managers, maintenance of a running application, monitoring the infrastructure, the state management, managing the application lifecycle around a Flink application, and the Flink internals themselves. So when customers need to know a lot of tools in order to run this themselves, including things like Kubernetes, Zookeeper for high availability, and many, many more open source tools. What Kinesis Data Analytics for Apache Flink offers is that it's a fully managed, sophisticated stream processing application solution that uses Apache Flink as the open source library and then lets you run the applications in a serverless fashion. KDA for Flink manages all of these infrastructure on behalf of the customer so that all customers need to care about is the application core logic. There's no infrastructure to manage, and customers only pay for what they use. So how do customers build an application using KDA for Flink? First, they create an Apache Flink application using the open source libraries, and they use an IDE of their choice to build this application in Java, Scala, or Python. And once the executable is created, they upload it to the service and just hit start, and they can just run the application in a continuous fashion. Now, with these three very simple steps, customers can get from creating an application to running it without having to worry about infrastructure management and run their application in a completely serverless fashion. We also have APIs that provide access to the application lifecycle as well as manage state. Now, you remember this from the previous slide. Essentially, there are layered APIs in Flink that allow customers to write code based on their preference. We have layered APIs across two axes. At the lowest level, you have the more verbose but also high control over your streaming data using the process function API that lets you process the most low-level operations, including managing state, stream, and time. And the data stream or data set API it's one level higher. It provides a good balance for sophisticated applications in that you still have a degree of control, but you don't have to write as verbose code as the stateful stream processing process function APIs. And at the highest level, you have the SQL and table APIs, which provide more descriptive code that's less verbose, but also provide less control over the streams themselves. But what that provides, what the table and SQL API provide, is a way to democratize stream processing and get it in the hands of more people. So it's a very simple way to get started with stream processing. And essentially, the new feature that we are going to talk about, Kinesis Data Analytics for Studio, is a wrapper around the table and SQL API, which is a very highly descriptive way to write your stream processing code in a very simple fashion. So Kinesis Data Analytics Studio is completely serverless and allows you to create stream processing applications very quickly. With a few clicks on the management console, you can launch a serverless notebook to query data streams and get results in seconds. If you're familiar with notebooks, a notebook is a web-based development environment. Common notebooks are Apache Zeppelin as well as Jupyter. In KDA Studio, what you'd get is an Apache Zeppelin notebook, which lets you iteratively build your stream processing applications using Python, Scala, or SQL, and lets you run your queries or programs in real time to look at your results and get feedback immediately and make changes to your applications as required. Because of this iterative approach, it also accelerates building these stream processing applications, and you can see them running in real time and get your results within the same notebook. Another advantage is that because both Apache Zeppelin and Apache Flink are open source projects, new features as they come will be found on Studio directly as we start supporting the newer versions. Another important and often used feature of KDS Studio is stream inspection and visualization. So if you just want to take a look at what's going on in a data stream and how the data looks, you can use a very simple select query, a SQL select query that tells you what your data looks like, and then you can make modifications to it. And there are a few charts, like bar charts and pie charts that are available on the notebook itself, which lets you also visualize this data as it's coming in. And because it's streaming data, you can see the charts update in real time, which gives a very good understanding to somebody who is developing a stream processing application for the first time about how their data sources look. The last thing I want to cover as a top feature on Kinesis Data Analytics Studio is the integration with the AWS Glue Data Catalog. The Glue Data Catalog allows you to store metadata for your application, for your stream processing application, that can be used by other applications as well. So something that you create using your KDS Studio application can be used by yet another application because you have the tables persisted, the structure of the tables persisted, so that they can be reused in multiple applications that need not necessarily be Flink, but also, let's say, by a different application that does not use Flink altogether. Now, building applications with Kinesis Data Analytics Studio is very simple. There are two easy steps. We spoke about the interactive notebook-based development environment that supports SQL, Python, and Scala. The next step is essentially, once you're happy with your code in the notebook, all you need to do is click a few buttons, and we will package that code for you and deploy your application in the fully managed Elastic service, Kinesis Data Analytics for Flink. So once you do that, you have two additional features, which is durable state, as well as automatic scaling that automatically come into play once you deploy your application, and you don't have to make any modifications to it if you don't want to. Right. So once you have your applications running in the notebook, as mentioned, you can also deploy it with durable state for in Kinesis Data Analytics for Apache Flink, and you can write, to multiple destinations, including Kinesis Data Streams, Amazon MSK, or a variety of connectors that Apache Flink supports, including JDBC endpoints, or you can also use custom connectors in a way where you can either write a connector on your own, upload the connector, the Flink connector as a jar into the notebook, and once you deploy that application, we'll package that connector as well, and you'll be able to write to any destination of your choice. So once you have an application running, one of the advantages that Kinesis Data Analytics provides is the monitoring aspect. So you have Amazon CloudWatch that lets you look at all the metrics and logs. So all your Apache Flink as well as Zeppelin metrics and logs are also published into CloudWatch. So that's a one-stop shop for your monitoring needs. And you also have the Apache Flink dashboard that lets you monitor your running jobs. And there's a direct connection from within the code that you're running in the notebook to the Apache Flink dashboard that lets you see all the 140 odd metrics that Flink provides if in case you want to see how your application is performing, and a lot more details of how the application is running on the Flink on the Flink engine. With that, I'd like to pass it over to Jeremy to go take you through a quick demo of Kinesis Data Analytics Studio.
Thanks, Deepthi, for giving that overview of Kinesis Data Analytics with Kinesis Data Analytics Studio. And I just wanted to take a few minutes to showcase a demo of Kinesis Data Analytics Studio and the functionality that you can achieve in just a few moments with a Kinesis Data Analytics Studio notebook. So right now on my screen, you're seeing the Create wizard for a Kinesis Data Analytics Studio notebook. And here you have the option of creating a quick create option with sample code, but you can also create a notebook with custom settings. And this would be specifying the source and sink, the scaling and monitoring options for your notebook, and just other configuration settings. But for now, we're going to stick with the quick create. And all we're going to do is give this notebook a name. We're going to link it to an AWS Glue data catalog database. And we would just click Create Studio Notebook. And you can see the defaults here. Log level is info. We have application level monitoring with a parallelism of 4 and a parallelism per KPU of 1. Now, if you do need other specifics and need to, for instance, be in a VPC, you can change those in that setting we were looking at before. Now, I've already created a notebook to go over in this demo. And this notebook is actually in a VPC. The reason for that is we're going to be communicating with an Amazon managed streaming for Apache Kafka cluster. So to communicate with a managed streaming for Apache Kafka cluster, you need to be within the same VPC, and you need to have the correct permissions associated there. So if we just scroll to the bottom, you can see that I've assigned a VPC to this notebook. And I've also configured a few other things, such as the Flink SQL connector for Kafka. And I've also specified a destination for the code to be deployed when we are ready to go to production with this notebook. So let's take a look at what this looks like using Kinesis Data Analytics Studio. So opening up the button on the main screen there, it brings us to this Welcome to Zeppelin homepage, where you'll see all of your notes that are associated with this application. Now, to communicate with our managed streaming for Apache Kafka cluster, we did need to put the notebook in a VPC, but that also allows us to do many things that are really, really useful within Kinesis Data Analytics Studio. So for instance, I have this notebook called Publisher, where all I've done is install some Python libraries, and I can now communicate with my managed streaming for Apache Kafka cluster. You can also do the same thing with a traditional Apache Kafka cluster or any Kafka cluster that you might want to interact with. So if we just execute this, I believe I've already run it, so it shouldn't install the libraries. They're already satisfied. But then I can run this second paragraph to initialize what's called a Kafka producer. What this allows us to do is now run a script to send data to our Apache Kafka cluster straight from this notebook. So forget about the days where you had to stand up your own EC2 instances, Kafka clients. You can just interact with it directly from the Studio notebook. So you can see I'm sending data here. This is happening live in the demo. Now, the data that I'm sending is stock ticker information. We have an event time associated with the stock ticker. We have the ticker symbol, and then we have a random price associated with that stock ticker. So let's go over to our analysis notebook and start taking a look at some of the capabilities that we can achieve within Kinesis Data Analytics Studio using Apache Flink's SQL and table APIs. So you'll notice right off the bat that I'm also leveraging an additional feature within Kinesis Data Analytics Studio called Markdown. So you can at any time go into your notebook for presentations or just to make your notebook look nice for analysis, and you can write HTML or Markdown right in the notebook paragraph. And when you execute that, it'll render and look really great for your presentations. So the first thing we're going to do is create a table called stock table. The stock table is going to be associated with a glue data catalog table over in the glue service through AWS. And this just allows us to ensure that the communication between glue and the schema that's in glue can be used by other applications when we define it here. So we're creating this table. It's got that associated ticker, price, and event time. We're telling it the connector is Kafka, and it's going to be listening for a topic called stock topic. And that happens to be the topic that we're publishing data to. We're giving it the bootstrap servers, and we're telling it to listen to latest. So let's go ahead and execute that. So it says table has been created. I can actually go over to the glue data catalog and see this table visualized here. So I think it is right here. And you can see all the metadata that's associated with that. We can see Kafka, event time, price, and everything else. So this is a really valuable feature within Kinesis Data Analytics Studio, and just one that I wanted to call out. And it's only been about a few minutes since we created this application, but I can go ahead and execute this cell to select star from stock table. And let's see how quickly we are able to see data coming from our Kafka cluster into the notebook. Once we see at the top right, this Flink job, that means that the job has started running, and we should see data within a few seconds. So there we go. We're getting data from the Kafka cluster. And at any time we can see this data live in the notebook. We can also choose to visualize this data in different ways. So if we want to see this visualized in, for instance, a bar chart format or a pie chart format, and there's many different ways to visualize this data. I also want to call out that you always have the opportunity to go in when this job is running and see the Apache Flink web dashboard if you want to do some troubleshooting or to look at more fine-grained details of how your job is performing. So let's go ahead and stop this job. That's a pretty interesting graph there. We can also do things very simple like a filter coming off the Kafka topic. So I want to select star from stock table where the ticker starts with AM, right, for Amazon. So let's see this data coming in. And you can see if we go to like the pie chart, for example, we're only getting Amazon data. So that's just a really simple filter process. Let's stop that. Next, I want to talk about a functionality called user-defined functions within Flink SQL. This is where, for example, you might have a transformation that you want to perform on your data coming in that isn't easily definable by Flink SQL. So the two examples that I have here, we are converting the date time coming in from the Kafka topic to epoch seconds. And this might make the data a little bit easier to work with. We're also converting all of the strings that are passed to this function to lowercase. So I just execute this cell or this paragraph, and we will define our two user-defined functions. And then once they're defined, we can simply call them in Flink SQL to see what that data looks like and to test out our user-defined functions. So you can see I'm calling to lower on the ticker symbol, and then I'm converting that event time to epoch seconds. So let's execute this one, and we'll see within a few seconds the data is successfully converted. And there you go. We have the ticker information is all lowercase, and then our epoch time was successfully converted. So you might have a use case where you want to externally enrich your data stream. And this could be if you have a CSV data in an S3 bucket where it has additional information about your data coming in. Or perhaps you have a rules engine that is defined somewhere else that you just want to link up with your incoming data, and that tells it where to route the data. So in our case, we're loading in a CSV from Amazon S3 that contains additional information about our companies, about the stock ticker information. And we can just simply join that table with our existing stock table, even though they come from different sources. And we can see that enriched data set live here in the notebook. And there we can see the company name, the company city, and the company state abbreviation are now right alongside the data coming in from our Kafka topic. Let's stop this. So of course, we also have window functions if you want to do some aggregations based on every 10 seconds or every 1 minute of data. We might want to get a count of the ticker for every 10 seconds. You would use something like a tumbling window. And a tumbling window just means a window that doesn't overlap. So you're going to have discrete 10-second intervals where we're getting a count of each ticker. And there we go. So the first 10 seconds, if we wait another 10 seconds, we should see an updated count. And there we go. Now, in a real world scenario, you'd want to give these associated event times. This example didn't do that, but just so you'd be able to distinguish between the results. Now, I won't run this one, but just to show you the use case, if you wanted to use a hopping or sliding window, this would be the same thing as a tumbling window, except these windows are going to overlap. And that would mean you're running for 10 seconds of data. You're going to do your same aggregation, but that aggregation is going to run every 5-second interval. So every 5 seconds, we would get a result, and that would be emitted from the data stream. And I wanted to talk about a really interesting pattern that we see in Flink SQL, or a really interesting use case, which is where we want to detect patterns within our data stream. So there's a concept in Flink SQL called match recognize, which allows you to define a pattern that you'd want to identify within the data. So this would be if you want to do things like anomaly detection or fraud detection, or just identify an interesting pattern within your data. You can do that quite easily with match recognize. The syntax is a little bit different than what you might be used to with traditional SQL, but really the only thing you need to be aware of is these 3 lines here. When we find a match, we're going to skip past the last row of that match. We define our pattern down here as we want to identify this pattern that we're going to define within the next 10 minutes of data coming in. And the pattern is as follows. We have a record A, we have many records B, the star denotes 0 or many, and then we have a associated record C. And we're defining B as the price of B is greater than the price of A minus 500. So what this essentially is doing is it's looking for a drop in price of over $500. And this could be indicative of there's something happening with the stock, there's there's some fraud going on. It's just a really simple example, but it's a really cool one that you can expand upon your own use case. So if we run this, I believe, yep. So we see some results here. We can see this is obviously sample data, so don't go and sell your stocks based on this information, but we can see that, for example, this ticker had a drop of $743. Originally, it was $900, and the last price was a little over 150. So that's a really interesting pattern, and we can also see when it initially was sourced and when the drop occurred. So I definitely implore you to read the documentation about Match Recognize. There's a really, really good documentation on the Flink documentation on how you can achieve this, and it could inspire you to identify patterns within your own data. Let's just stop this. So we can also do things like top N and deduplication. I won't run these just in the interest of time, but just want to showcase the examples. The way top N works is we're really just creating a row number over a partition of data. And when we give that row number, it's going to uniquely identify each record within the table. And that allows us to select from these row numbers where the row number is less than 10. That would essentially give you the top 10. And we're, of course, within the partition by, we're ordering that data set. So you're going to get the top 10 results from your stock table. Now, the deduplication works very similarly. We're doing the exact same partition by order, except in this case, we're only selecting the first row for each record. And that would essentially deduplicate any of the records that are coming in. So what I want to showcase at the end here is that we have the ability to sync this data out. So, it is interesting to generate these insights and visualize the data in this Apache Zeppelin notebook, but we also might want to write this data out to, for instance, Amazon S3 and do some further analysis in batch or something like that. So what we can do is create a table called sync table with the associated schema that we had before. And we're going to use the file system connector. And that essentially tells it that it's going to be writing out to a file system. And our file system is Amazon S3. So I'm telling it to write to this bucket called interactive applications in the format of CSV. And when we run this, and then we run an insert into command, we should start to see data appear in Amazon S3. But I actually want to showcase this in a different way. What we actually want to look at is how can we deploy this application so that we have the necessary safe measures for a production application, like checkpoints and snapshots, to ensure that if there's any failure within our application, we don't lose any data. So I'm actually going to come over to this notebook that I've defined. It's the exact same thing as what we were looking at, except it doesn't use both Python and Scala. And that's a necessary requirement for deploying to Kinesis Data Analytics, not Kinesis Data Analytics Studio, but the actual application cluster itself. You cannot mix and match Python and Scala. You can mix and match SQL and Scala or SQL and Python. Just keep that in mind. So I'm going to go to the top right here, and I'm going to build the application. It's given an application name, and it's going to write to the S3 bucket that we defined before. And just in the interest of time, I can showcase what this looks like in the bucket. We do have our data set here. It successfully wrote out to the Amazon S3 bucket, and we can see our code packaged nicely into a jar. From there, once it's built, you can also come here and click deploy. This is running right now, but I did this previously. I deployed this application to Kinesis Data Analytics. And let's just come over there and see what that looks like. So here's my application. And you can see it's doing the exact same thing as we were looking at in the notebook. It's reading from a Kafka topic called stock table. We're creating that window of data, and we're casting everything to lowercase. I know it's a little hard to see in this DAG, but just trust me, it's doing the exact same thing as the notebook was specifying. And when this is running, we can also test it by going to our publisher notebook. I think it should still be sending data. So we can actually go over to S3 and verify that our data was successfully written. So let's go over to here. We had our partitions. Let's go into one of them. And we can see that data has successfully been written to our notebook from our Kinesis Data Analytics application that was developed in a Studio notebook and deployed to Kinesis Data Analytics. So I hope this was interesting, and I definitely look forward to seeing how our customers utilize these resources and utilize these tools to develop really exciting and interesting applications to help their businesses. I'm going to take this time now to pass it back to Deepthi to close us out and recap what we've learned today.
So thank you, Jeremy, for the demo. So key takeaways from today's session. You can use Kinesis Data Analytics Studio for a wide variety of use cases. You can do something as simple as stream inspection all the way to complex stream processing of a wide variety of use cases using very simple SQL code. You can use a combination of SQL, Python, or Scala. And you can use the notebook interface to develop your applications and very quickly deploy them as a continuously running stream processing application in minutes. With that, we want to leave you with a set of resources and some materials to get you started, and we will be live for Q&A right after this. Thank you for attending this webinar.